Welcome, everybody. So my name is Simon from Intelligent, and for the last 10 years, I'm consultant at Intelligent, and mainly my job is to advise customers in building up data platforms or data-driven business models or use cases. And yeah, a lot of stuff happened in the last 10 years on various platforms, but I think this one is special. So I think it was 10 years ago when the first customer came to me and said, okay, I want to build Datavault and I want to build it on Hadoop. And I was like, you could do it, but I couldn't convince them. So at the end, we've done it, and it took us a lot of work, but it worked at the end. But it wasn't fun at all. And some other customers tried it. One that really got it working was the one that built it on BigQuery, but it was no fun at all. And so my assumption was it's not a good idea to build data vaults on big data technology. And then a year ago, a customer came to me and said, okay, we already have Databricks in place and we definitely want to do data vault. And it was again like, but they said, okay, we've tested it and it's great. It's really good working. And I was, okay, if you say so, then we do it. And this is what I'm doing for a year now. And another customer joined in between. But so we are doing Data Vault without Datavault Builder. And as they announced this year that they can do Databricks too, I thought, okay, now my world is complete. It's a better place now. I have everything in place I need. So this webinar is very close to my heart. And it's really time to talk about that and look at the great new features. And with that said, I would say let's take on with the introduction route. And I hand over to Thomas.
Thanks a lot, Simon. I'm also with Intelligent, but compared to Simon, my career at Intelligent is only about half as long. So I've been a consultant at Intelligent for around 4.5 years now, have worked with different technologies, have seen multiple data platforms, and I'm almost as excited as Simon that Datavault Builder now also runs on top of Databricks. I can fully share the excitement that we had when we read that announcement, and today we'd like to pass that excitement on to you and hope that we can get some of you just as enthusiastic about this combination. And with that, I'll hand over to Peter.
My name is Peter Billes. I'm working since 2010 for Datavault Builder, and yes, I was on the same path. We were always like this NoSQL or not directly relational SQL databases. We were always looking at it, testing it, and saying, okay, is the performance sufficient? Does it work? Does it support all the features that we need? Does it support security? And Databricks is really a platform that showed that they really support and can compete as well with classical relational databases. So we started building up the support, did a lot of testing, and now you hear that Datavault Builder on Databricks is offering the same functional coverage as on the other platforms that we support. And we would start here with a small poll to activate you all. And I would start that if you want to tell us, like, what are your main challenges today in your current project? Don't worry, it will show just the aggregated numbers that we will share then here in the round, but that you can tell us a little bit what is driving you today and potentially in the next year. Good. I think most of the people that wanted to responded, and now some more answers are coming in. Good. So let's share now the results. And we see that there are many different drivers, missing data model that we will look at today. Data quality is, I think, since I started the issue, effort to implement new things, it's a main driver what we will look today. Complexity of having too many tools as well, something that we will check today. Operational stability is potentially not something that we can address directly in the webinar, but that we are covering. It's related directly to high maintenance cost. And my favorite topic, not understandable by business users, that was one of the main drivers that we started the whole journey here. So that's a good start. Thank you for participating. And I would hand over to Thomas to start the first bit.
All right, then let's start with the agenda and let's quickly walk through what we are going to cover within the next hour. First, I'll lay off a bit of the platform foundation, the core concepts that we'll be using today. What is a lakehouse? What is the Medallion architecture? And where do we see Datavault in this picture? Then we'll get to the highlight of today's webinar, a live demo, which Peter will guide us through. And after that, we'll give you a technical reality check. What works well? Where are the limits? And where would we place this setup in our reference architectures? Yeah, and I think as already said, please ask questions along the way. And if we still have some time at the end, then we can take a dedicated look at the Q&A and go through some open questions. So, next slide, please. Let's start with the lakehouse, the definition and context. So for quite a long time, people claimed that Datavault is incompatible with lake architectures. And that's not completely made up because there are a few typical objections. Datavault creates too many tables for big data. So is that even performant on Spark? Datavault has too many joins, hubs, links, satellites. Isn't that a performance killer? And do I even need to add that additional complexity if I have already a modern lakehouse technology? On top of that, platform features increasingly overlap. Some platforms provide lineage out of the box, some provide historization. So people keep asking themselves, why should I also put the Datavault hat on? And we shouldn't underestimate the initial effort and the steep learning curve that comes with Datavault. In many projects, that time isn't simply available. So it's exactly this misconception that we want to address today. And we want to show where synergies arise, that this isn't a conflict, but actually a combination of strengths, that Datavault fits very well with what we want to achieve in modern lakehouse scenarios. Yes, then let's start with the definition of the lakehouse. Here we have the lakehouse definition that Databricks uses. A lakehouse combines the scalability and flexibility of a data lake with the structure and reliability of a data warehouse and provides a unified platform for all data workloads. Let's go on with the next slide. So historically, we come from the classical data warehouse approach, focusing on structured data. Later, data lakes were bolted onto existing systems to handle unstructured data for data science and machine learning use cases. Today, these worlds are converging into a single system that should serve BI and reporting, enable AI and ML, support streaming near real-time, and still handle classic ETL batches on one technology platform. So, next slide. We break this down into 4 domains of a multimodal data platform. First, we have analytics, consolidated and clean data for BI and reporting. Second, AI and ML, large volumes of raw or lightly processed data for advanced analytics. Third, streaming, real-time or near real-time processing. And fourth, or finally, classic repeatable ETL pipelines. So the idea is that one platform can support all of these types of workloads. So because the requirements on the platform are growing, the platform itself needs structure. Databricks uses the term Medallion Architecture for that structure. At its core, this is an organizational principle inside the lakehouse. Data flows through several layers and is refined from layer to layer. Bronze, raw, unchanged, historized data. Silver, cleansed, validated, integrated, and modeled data. And gold, consumption-ready data optimized for specific use cases. So this gives us 3 clear responsibilities, 3 layers, 1 platform. Now let's drill down into the individual layers. So let's start with the landing zone, the raw layer. This is where the raw data from the source systems arrives, completely unchanged. The purpose here is to know when data arrived, to ensure auditability, and to enable fast error analysis. Because if something goes wrong later in the process, we can always fall back to the original data. Then we move on to the bronze layer. This is where the first standardization happens and where we start to apply compliance requirements. We decouple ourselves from the source system on a technical level. We ensure a minimum guaranteed level of data quality. And first compliance aspects can already kick in here, for example, separating PII or other sensitive data. Let's continue with the silver layer. And this is where the actual business modeling takes place. Here we cleanse, validate, and integrate data and build a consistent business-aligned data model. The goal is that everyone shares a common understanding of the data. Servers should also be stable with respect to changes in source systems. It is our central integration layer, and we keep a traceable history of states so we can always see what was calculated, when, how, and why. Finally, we have the gold layer, where the refinement and optimization of the data happens. Gold provides the data for reports, dashboards, AI, and ML models, and it's also the layer that enables self-service. Business users can directly work with trusted KPIs because the relevant quality checks have already taken place. That's the strength of the gold layer. So then let's quickly sum it up. We reduce these three simple statements. Bronze is where versionizing and standardizing takes place, initial standardization and compliance, versioning and historization of data. Within the silver layer, we model and integrate data. This is where cleansing, validation, integration of the data takes place, and we build a consistent and business clean data model. The gold layer is where we optimize and refine our data. We provide refined, documented, and trusted data for reports, dashboard, and AI and ML models, and consumption-ready data products. So, in short, we have three clear responsibilities, 3 layers, all within one platform. Yes, and with that, I hand over to Simon.
Thank you. So, yeah, I would try to start from there. Before I do that, I would like to revisit the promotional slide from Datavault, because this applies everywhere, and of course also in our lakehouse architecture and in our Medallion architecture. So why are we doing this at the first place? I think one of the main advantages, and I appreciate the most at Datavault, is that you have a model and that gives you a uniform understanding of your data. And you don't have it somewhere or just for a business case, and after you implemented the business case, you throw the model away. You have it in your heart of your data platform, in your server layer, and you have it in your physical data model. And so it helps us a lot to put all the governance up top of that. So it helps us on even technical speaking in parts of looking at the whole lineage from source to the gold layer. It helps us in putting rules on that, metadata up on it, or permissions and roles and security up on that. So we have that centralized place, and of course you can achieve this also with another approach like 3NF from Bill Inman and hub and spoke architecture, stuff like that. But from my perspective, there are a few more advantages, and that fit very well into the combination that we have here of lakehouse architecture and Datavault. So I call this the 3 pillars of Datavault's added value. So I already talked about the understanding, the uniform understanding of the data. And what makes me the most fun with Datavault, and I'm working with Datavault since 10 years too, is that if you stick to the methodology, you can build up very modular business rules. So you can build very small pieces of your business rules and do that in a modular way. And with that, you have much fewer dependencies on that. So normally the business comes with its requirements and they don't know, or maybe they know what they want, but they don't know what they need. And at least they don't know how the data really works. So per definition, the business rules we implement have to change. And with Datavault, we are prepared for that. I think this is something that will break up your flat and white table or your 3NF model, at least when you have different versions of your business rules. But in Datavault, it's the way we're working. So at least this helps us a lot in implementing new stuff, changing stuff without touching the rest of our model. And we don't have to retest that and be afraid of side effects and stuff like that. So at the end, it gives us stability against changes from the business. Okay, coming to the middle pillar, I think Datavault scales in more ways than I've got here with me on that slide. But I think that those three are the main characteristics in the combination of Datavault and Databricks. So as you can imagine, it scales very, very good in the loading performance. So theoretically, we can load all tables in parallel. So yeah, practically, maybe some of you know, there are some constraints and we have to iterate through some processes, but still the loading performance is still great and we can still scale a lot and a lot more than any other solution I can think about. Another big advantage is the scaling on the development side. So normally I have so Datavault is built up of small patterns that I use every time for every table. So I have, I don't know, a handful of maybe up to 10 patterns that I use to load all my tables. And so at our customer projects, maybe we have the bigger ones, but there are thousands of tables at least. And they have to be handled all at the same way. So all of them or each of them is very easy to handle, but it cannot be an approach to handle each of them manually. So I can't define every single table and I can't model every single table or orchestrate it. At least I have to give that to an automation tool. In the best case, it's Datavault Builder. So I can work on a more abstract level and be happy about the very easy, simple pattern and let the automation tool do the best. And for me, it's very easy and I can be very fast in developing new things and add new things to my model. Then I have a third point, and I think this applies very well to the lakehouse architecture. I can scale in the modes of my source system. I will pick that up on the next slide. So classically, I have batch data and I'll pull that from a source system, but there can already or also be other modes like streaming data. And with the patterns I have in place with Datavault and Datavault Builder also serve them to handle multi-temporal data and scale with the loading performance. I am able to scale on the modes I have on the source system. I pick that up and tell you what I mean on the next slide. I want to pick up one point from the governance pillar from last point. And this is it's again about streaming data. I think from my perspective, it's more and more streaming data is coming into the companies. So mostly we have some microservice architecture in the source system, stuff like that. So it's typically there are more changes in the source data that I have to consume. And my platform should be happy to handle those changes. And I think Datavault makes us very easy. Of course, we can break physics. So there have to be some slight rules how structures can evolve. But at the end, it makes every normal involvement of structure very easy to handle because we can just add another things to our model and we don't break the whole model at all. So I want my platform to be happy to handle changes, make my life easier and the life of everyone that is working with my platform at least. So I promised to pick up the design pattern topic again. And I think it's mainly about those two modes I have on my platform. So talking about batch data and streaming data. I don't know what your experience are or what your feelings are. So my experience is that in the last years, there are more and more applications that deliver streaming data to a platform. It's more relevant to handle IoT data, to handle tracking data in our analytics, in our BI. So it's more and more a topic to handle both of those integration patterns, batch and streaming. And the main, it's not a problem. I think the main challenge is that they are completely different. So I can't handle streaming data as I handle batch data. So I'll tell you what I mean. When I handle batch data, I go to my source system and I took this, I would say, call it bucket. I took a bucket of data. I asked my source system for a specific snapshot. Please give me all the data you have for that snapshot. And in best case, I do it in Delta mode, but I have a snapshot, and this is the thing. With this snapshot, I can control every pattern and every data process on my platform. So I can historize with that, I can version that, control every other thing, and just stick everything to that snapshot. And it's very easy. And it's I pull the data periodically, so it's on a daily basis, hourly basis, doesn't matter at all. I'm not doing this all the time. I have times where I don't put any data, and I have the chance to do other stuff instead. So this is completely different than streaming data. So when I look into my stream, I only see what's currently happening. I don't know what happened the last 3 hours or yesterday. I have to continuing processing my stream and collect all the data to have a bigger view on the overall picture. And to apply my analytics on this, I need to collect the data and don't stop with that. So when there is an error or something that I need to reprocess my data, I cannot stop reprocessing the live data. So I need to scale to reprocess the data in parallel to processing the live one. So this is something that is completely different. And I've wrote here potentially not deterministic. So, but at the end, I think we are engineers. We know what that means. It's not deterministic at all. So we have to expect that we have data that arrives later. We have data that is not in the correct order. We had duplicates in that. So at the end, it's not bad. So we can handle it all, but we must handle it. Otherwise, we will. I think in German it's we will break our legs. So it's not either way if you don't handle it. So, but if we do it, it's all fine. So at least this takes us to the last point. When we want to make the normal process like historization, versioning, or every other getting a data of that, we always have to handle 2 timelines. We have to handle the timelines when we receive the data, the snapshot like it is in batch, and we have to handle the timeline when the data actually appears in the source system. So it's the business timeline at the end. And this is the point where Databricks and Datavault helps us a lot. So how we solve it is we have the batch and the streaming data coming from our sources or pulling from our sources in the batch case. And we have powerful tools in Databricks like Spark Streaming and DLT, and that helps us handle our checkpoints, making all the reprocessing. We can scale it to do the reprocessing, all stuff like that. So we have these, it's 2 modes of data processing, but at the end it's in similar structure. So they are all ending in bronze tables. And so we will be doing this, handle batch data in a batch mode, handle streaming data in a continuous mode. And at the end of the bronze layer, we have everything in place we need to do the next normal processing and change the mode. So now we can even integrate this data from the 2 different source types into one hub and satellites, because we have a pattern that can handle the normal snapshot timeline from batch and for another satellite, and for the same hub, the 2 timelines that we need for the streaming data. And then we can switch to micro batches. And I would claim it's no problem to go down to a minute in micro batch mode. And I would also claim for 99% of your use cases, this is what you're looking for. Of course, there are edge cases if you need real-time analytics on your shop floor, stuff like that. But let's talk about that another day. I think for 99%, this is what you're looking for. And this is where Datavault helps us a lot with the high loading performance and the scalability that still keeps us being able to process all the data from bronze to silver to gold. So, and St. Thomas raised the question at the beginning, and I explicit not answer it, but implicit too much now. So yeah, is Silver the appropriate layer for Datavault? Yes, I think it's all clear now. But I think at the end, I hope you get a slight feeling that Silver is not the thing that you have in mind when you think about your classical core layer. Is of course Silver is core, but Silver is much more than your core. So there could be an analyst or data scientist that want to have a centralized place to calculate their features. And this is also Silver. This is all good. So we can't stick to our data warehouse pattern and look at the lakehouse architecture when we are building a multimodal data platform. And how that looks in practical and with the Datavault Builder, for that, I will hand over to Peter.
Thank you. So I will try to take over the screen if this is okay. And while I'm doing that, I can start a second small poll that I get a minute to do that. It would be about, are you already using some kind of automation for your current solution, that we get a little bit of overview, and we can maybe as well explain then the differences between the different approaches. Most people were not reflected on this graph, but are using some kind of automation, potentially some self-built automation and other stuff. So let's start now with what we're doing and what is the target. And the main thing is, what I always say is, the main target of the Datavault Builder software is not to build a data vault, it's about creating more business value. And how can we do that is, one thing is to do the right things. So to allow to create your stuff in an agile approach. So start small, build incremental, but this is not the value directed to the business user. For the business user, it is that you reduce the cost of delay, you deliver exactly what the highest priority is to them. So if they have end of year reporting that is coming up and priorities change, that you can react to that. And yes, the Datavault approach helps us to do that. So as well, Datavault modeling in the core is not an end in itself, it's a support feature to achieve business value. The second thing is doing things right, and these are the two arrows pointing up. If we use automation, we use less effort to doing the things that we need to do to create tables, to write loads, to create documentation and data lineage, to lower maintenance costs by having a resilient approach to the whole thing. And the last thing what we need to do is deliver early, because this is one crucial point if we start any project in the data space, is that if we don't deliver in time and don't show the business value early on, even if the project would be successful maybe in the long run, it could get stopped as we haven't shown enough output. And how are we doing this to achieve this higher productivity, earlier delivery, focusing on what really matters? We start with a business view. Instead of starting with Databricks, instead of starting with tables, which is all an important part to deliver the solution, is in the process, we start with talking to the business user. And it's about looking on what do they want. Depending on industry, it might be the customer, it may be a sales order, it might be account, and work from there. And many people of you that are for a long time in the industry know that this is not new. We used Irwin, we used Power Designer, many modeling tools to do this kind of models. The problem was that if we did this kind of modeling, it took us then as data engineers days, weeks, sometimes months to deliver back then the build solutions to the business users. The business user forgot a little bit what we did because in the meantime they created some kind of Excel solution. So the difference here in this approach is that while we're modeling, and we're modeling here logically and conceptually, we are translating this into working code in real time. And this is what we will see in the demo. And if you look now how this looks on Databricks, it's very, very similar to all the other platforms we support. We have the ingestion layer, which is the bronze layer. And yes, this can be already some streams coming in. It can be other processes directly by Databricks. You could use one of our ETL connectors to connect that, and we pick it up from there. And the nice thing is that if you have ingested the data and you want to bring it into the raw vault, we are able to deal with many different sources. We can do full loads, we can do just change rows, and we can deal with this real-time data, because real-time data by definition, depending on the technology, arrives out of order. Not always, but it can. So like if you have a Kafka stream, it's not guaranteed that the messages will arrive in order. This means that while loading into the next layer, we need to sort out the stuff, and we will take care of sorting this in correctly. So we will load your satellites in the data vault already in the right order. And as we heard before, we will attach another timeline on when did we got knowledge of it, and by this creating already all this bitemporal stuff. Why do we need to do that? To sort out live streams, to sort out as well redeliveries, to check if we got duplicates delivered, maybe because some stream broke and redelivered by accident some messages. All of that is already covered into the integrated, persisted, and historized view. The next thing is that we could already output the data as it is. So what will our output module do? It will join together all the necessary data from all the tables. And as we have a historized storage, it will ask you now what is the perspective that you want to get. So it will limit it to as of now view, or it will output the full history. The next thing is that you say, okay, now I deliver the data as it comes from the source, but that's not perfect enough. So in the next step, with the next iteration, you can start building business rules. And for most business rules, we want to join as well together attributes from different entities in the model, from many different systems, build our business rules, and now, as a second solution, we can output them virtually directly to the output and mix them with the raw data. But if this is not performant enough, we can materialize this layer, or even if we need to have the history, if we need to really report on as well on the rule results, at which point in time did we reach or calculate which value, we can store this kind of information in the so-called business vault. But it's really from bottom up the different layers of complexity. So either outputting just the raw data, adding some derived values, or even persisting the derived values. The main goal, and this is what we are focusing on, is always at the end delivering the output in exactly the format as the users want it. So if they're used to dimensional modeling, if they have Power BI, Tableau, Qlik, that's perfectly fine. They will get dimensional output. If you have some application you're serving, you can get 3NF or normal form output. If you want to have flat tables for your data scientists, that's fine. If you're working more with data products, that's fine, because in all this pipeline that we have here, we are more normalized than what you need on the output in the gold layer. So this is not really an issue, and we can output that directly. And the point is that we don't need to just bring the data from source to destination, but we need to support the full development lifecycle. And it starts that you set up your infrastructure. With Databricks, you just can create a new database. For Datavault Builder, we deliver you the containers so you can run them on premises, you can run them in your private tenant, you can get the software as SaaS, whatever you need at which point in time, but guaranteeing you complete data privacy if necessary. The next thing is that we have built-in data profiling, so you can look already at the data, do some visualizations while the data gets in. You can do the modeling part. We will generate the code for you. Always at the same time, documentation and lineage is generated, so it's always up to date after you finished one modeling step. And usually other tools cover only the modeling and code generation part. And they forget about that, yes, we need to look at the data as well, that we need to deploy the code. And this is where we differ from many other solutions. It means automatically your data model changes can be versioned in Git. It will automatically calculate your deployment scripts. And not only that, it will calculate for you as well rollback scripts if necessary. We have REST APIs for automated testing. If you get tired of manually deploying stuff, we have REST APIs for automatically comparing different environments, creating the deployment scripts and executing them. with operations built in, so you can schedule within the tool. So one of the questions that we had at the beginning, that you need to have all of this covered in all the projects, but in many projects, this is covered by 5 or more tools. I think usually we see something between 7 and 9 different tools covering the full process is now covered by Databricks as the database and Datavault Builder on top of it as the orchestration tool, modeling tool, deployment tool, scheduling tool. And the nice thing is what we have in common with Databricks is that for everything that we do, there is an API. So if you want to automate any of these steps further, you're free to do so. So let's jump into a live demo. And after we see this picture, there was one question typed in the Q&A section, and this was, where do we look at the data quality in the silver layer? Do the business users need to be involved or not? And that's a very good question. There are parts. Oops, I think I shared my screen the wrong way. No, it should be here. Should be okay. Now, there are things from a technical perspective that we can already cover. And this is what I will show in this demo. This is the part about like the right granularity, the things about cardinality, where we know if this doesn't fit, the integrity of our data model is not correct. And we can fix that and we can stop loading bad data. But we have as well in the business rules section the opportunity to check for business validity. But we don't know from a technical point of view, if we are not working long enough in the company that we have as well business knowledge, if like it is okay that the order has no customer. Maybe it is in some companies it's not. Depends on if you sell over the counter and stuff like that. So here we need to have the input as well. Which kind of business checks do the users want to do? Yes, we know maybe if like we have the number of customer doubled from yesterday, that this is probably an error. Yes, we can check that, but some smaller stuff not. And I really like this. I had a colleague when he presented about 30 business users that we had a success rate of 100% in all the tests, and we tested everything they defined because they forgot to define any business test. Then they realized that yes, there is as well a responsibility from the business users to say what for them is valid business input. Good. So let's start here with the live demo. We have here in the data model the blue boxes. These are the concepts. We have lines, which are the relations. And we have the big colorful bubbles, which are subject areas. And if you know the Datavault Builder, I have seen the demo before, this is very boring because it looks exactly the same like on every other platform, because we are abstracting on how this is implemented. And every time we add here a new object, and I could add here maybe a boat object because some airports do use boats, I've learned. In the second I'm modeling it, it is sending a command down to Databricks, and this table is already created in Databricks and it's waiting for data. And by using standardization, you don't need to define any patterns. The patterns are coming with the tool, but don't worry, everything that we do is locked in log tables in the database. So even if you would turn off the Datavault Builder, everything what we have done, you will see. And what I mean by standardization is that like this table, the hub table needs to have 4 columns. It's defined by the Datavault standard. That we have some technical post and prefixes is defined by the internal naming standards that are documented, so you don't need to take care of that and can just use what it is. And this, coming back to one of the problems, maintenance cost is lowering maintenance costs because you know that every hub is created the same. You know that everything is documented. And if we need to send update scripts because Databricks maybe introduced some changes and we need to change the physical data model, even in 2, 5, or 10 years, we can send you update scripts. And we are doing this already for other databases for more than 13 years. And still our first clients are able to upgrade to the newest database versions because we're sending them the update scripts. So here, the tool is talking directly to your database. And after we have created our data model, and we can browse through the data model as well, because this is a little bit bigger than it is. And this model was created directly in the Datavault Builder. I loaded it from my Git server because my colleagues prepared that for me, but I could import that as well from any existing solutions if I can get out somehow the metadata in a reasonable format and use the APIs or the import tool here to import your existing metadata. So this is step one. We have created our target model. And in this case, the business user tells us, the first thing that I want to know is how many flights do we have at which airport, because my business is servicing flights, so get me this information first that I can judge on which airports could be potential clients for us. So we take the business model and we decide to implement now the flight concept first. So we go to the staging area, and here we have many different connectors to connect to databases, to connect to APIs, to connect to NoSQL sources like Kafka, as we heard. We could pick up here some stream data that is directly in Databricks landed. And after we create a source system definition, Datavault Builder goes there and it looks on the existing tables, reads the metadata and offers it here to create a ETL load to import the data. In that case, I'm reading directly from Databricks, so it's even an ELT load. I can select the columns, I could select a subset, and I'm skipping now a lot of options because there's always a standard flow, but you could break out, and if you say, no, I have something really special, you could go in and even override some of the default patterns here, but do this only if it's really needed, because in most of the cases, I would say 98% of the cases, the standard workflow works out of the box and it has a much lower maintenance cost attached to it, because we can like check off if some columns were removed, we can do self-healing if like data types were extended and stuff like that. I will skip as well all the delta loading, bitemporal loading, subfiltering. I will skip the data catalog features. They're there in certain versions of the Datavault Builder. And I will just continue with a simple implementation of a standard use case. So I just say that I want to load the data immediately. And this is the nice thing, that we're not just creating like the table, we're not creating only the ETL workflow, but it's loading really the data in the same moment. So after everything was created, it starts loading the data, it updates the documentation, it updates the data lineage, it makes everything ready for deployment. And this means that a few seconds later, the data is already loaded here into our Databricks database. But if I look at it, too many columns, I go to the data viewer. Let's have a short look on this table. Maybe let's do a value distribution. And we see that Southwestern Airlines was the airline with most flights in my data file, which looks okay. So let's go on. And this is the difference to other ways of working, that you are usually working in the blind or you're working with different tools. You need to combine it. So now we can connect the stage data directly with our data model, and we need to do this only once per entity. So we select the source system, the table that we just created. And here our business user is maybe telling us that the flight number is the business key, and please don't forget the date, because the same flight number can be reused on different dates. And here we have a business key checker, and the business key checker is now checking against Databricks if this key combination is unique. And this is like one of the first tests that we always do, that we already can give feedback to the business user, even they haven't specified any checks. And here the carrier code is different. And they say, oh yes, sorry, I forgot. If you look here at the data, the flight number is not what you usually know as flight number. It's only the number part. So we need to add here the so-called unique carrier code. Let's validate it again. And we have already a second iteration. This is this agile way of working. It's not about failing. It's about failing early. If you fail, that you get feedback and you fix your stuff before you go on. By the way, I'm doing a lot of POCs every year, and in nearly all of them, we find some data that is not unique according to business definition. Even they used it already for several months or years for reporting. I will skip here prefixing to bring different data sets together or keep them separately. And again, here we can load the data immediately, and we can create as well all the satellites where historization will happen. It will automatically create a as of now optimization. It will track automatically if something was deleted in the source, if it was already temporal source, like end of day processing that you're importing or Kafka Stream. It will create bitemporal satellites and load the data, and you're done. You have a working implementation from source to your raw vault. And database is being loaded, but this should take only a few seconds. You see it's a live demo. Let's check the hub was already loaded. That's good. I hope in the meantime the satellite finished as well. Yes. So I could go and I could look at the data lineage in here. I could go to operations. I could start my jobs. I could schedule my jobs already, and that would be working. The problem is that so far nobody can access my data. I have loaded in the raw vault, and this is now where a lot of Datavault projects report that they were having troubles or even failed getting the data out. And here, this is where we solve as well your problems automatically. Because we're model-based, we can now go in and start selecting columns from different source systems, from different entities. We can select if we want to do as of now data, as of then data. It will select the right temporality. So all of the complexity of writing the joins and bringing the data together is done with our pre-built patterns. You just select what you want to achieve business-wise. So this was how it was before I saved it. Now I can save it. It will rewrite all the joins to bring all the attributes that we need together. You can select here as well multiple interfaces to stack process data and stuff like that. I will not go into this detail. It's just here. And maybe the business user calls me back and say that he wants to report on the weekday. We can harmonize column names here. Everything is model driven. And the nice thing about this is that this is not working only for one database. We can generate it for Databricks, but you could generate it as well later on, maybe in 5 or 10 years for other databases based on the same model we have. Good, so let's preview our output. Now the next step would be, do we need to have some derived values or not? I don't need them in the first step. I just want to present my data to the business user, so I have a last look here, and I will publish that and later on come back to add some derived values. And this is the minimal run through the full Datavault Builder system. This means now I can call my business user and tell him, hey, look, I've created your first data set for you. If I grant him the permissions, he can now go take his day of the week and create his first report. And for sure, he will call me back and say, I can't do anything with the numbers because I don't know if this is Sunday or Monday, depending on the region that you are. So you need to improve that. And that's good. But we have already delivered the data. He can already check on first things. Maybe he could look at the flight day as well, combined with the number, and then figure out based on the date what means what, and start giving us feedback. If you look now at data lineage, it goes through all the layers from source to destination. The nice things with Databricks is now that we don't need to rely only on that because we're working directly in the database. We can switch to the Databricks view and we can go here to the lineage and look at it, how it looks like at this level. And I could here even go down to the level of single columns, and I can go through all the layers until the layer where it's published. And we see really here where the columns are coming from. So I can click here of the day of the week. and go through and see really my lineage through all the layers where it's coming from. Still, you have all the metadata in the tool available. You can access it through views, through REST APIs if you want to implement it with your company-wide approaches, and we can go now in and compare it here directly against other environments, against Git, and check in our changes into Git. And this is only part of what the Datavault Builder is doing. And for everybody that's seen the Datavault Builder demo for any other database, it was really, really boring because it works exactly the same as for other databases. Just the code that we're generating is completely different because we're generating here now code at the level of Databricks. So if I would go and refresh this here, we should see here our new hub boat that I created. We have the comments on it. I could change it here and it would go as well back to the front end, but I would complete here my demo and hand over back to Simon.
Yeah, thank you. So I will take over the screen 2 again. Oh. This looks good. So yeah, as Peter already mentioned, so I think it's very boring for people who are already using Datavault Builder. I will take the focus a little bit more to the people who are using Databricks and thinking about using Datavault Builder, or maybe at least both of them. So what brings us that approach from combining those two tools? I've really talked about a lot of these points here on that slide, so we can skip performance. I think I've talked a lot about that. So loading performance is great. And just to mention that, Thomas at his first slide said that, okay, there is reading performance could be a problem. As we see in Peter's demo, this is a problem of the processing from silver to gold layer, and it's not the problem of our BI tool, at least, because then we again have our flat structures or 3NF model or flat and white tables, whatever our BI tool needs. So this cannot be the problem of our whole platform. So from my experience, this is not the thing. So we already talked about the harmonization. We saw the end-to-end lineage with in Peter's demo. So Datavault Builder brings us a straight model, and Databricks gives us a centralized governance on that model. We already talked about the modeling and the strength and the robustness of the model. One point I want to pick, and I really love that one. So we have that model in the gold layer, and we can connect most of the BI tools to that, because Databricks gives us a SQL endpoint. I think most of the BI tools only want to talk with that one. What is coming more and more at our customers is that they want to talk to the data. So I think LLMs is one of the things that will be next to BI tools, or it is already there. So Databricks comes with Genie. Hopefully you have heard of that. So you can configure Genie to make you able talking with the data, create small diagrams and stuff like that. So I think this is really the thing that is coming, or that is already in place. What I like on the integration side, so Peter showed us Datavault Builder is able to integrate, but so if you handle streaming data, you have those powerful tools from Databricks to handle all of them. And there is Lakeflow, there is the autoloader that helps us a lot and makes us life very easy, ingesting data into the platform. And already talked a lot about that. We have the multimodal usage, not multimodal ingest. I'll come to that a little bit more on the next slide. There will be some analysts on our platforms. There will be BI stuff on our platform. And we can put this all together in one platform and using the same data foundation for all of our use cases and all of them. So how can that look more technically? So it's not infrastructure, but this is our reference architecture. And I've adapted it a little bit to Databricks and Datavault Builder. So we're talking about modules a data platform consists of. I will talk you through this data process. So we're starting on the left side with the data sources. So of course there's some microservice. Because I think it's a common example for streaming data. And because this is a reference architecture for Azure Databricks, we have services like the Event Hub here in place, and others too. So streaming and ingesting streaming data is one of the processes we have here on the ingest layer. I will talk about data sharing, I think another day, not today. It's one of the great features that we can use to ingest data or to pull data. And at least some or most of our sources are or maybe on-prem, so we need some kind of storage to pull the data in. And then we can use the Databricks tools like Autoloader, which makes us life easier to put all this data into our storage module. And then what's happening here is we have the layers in place, so bronze, silver, gold, and we have Datavault Builder that is processing the data through all these layers. So it's taking the bronze data, processing it into a data vault model and silver layer, and then after that, serving up with black, white, or dimensional structures in the gold layer. And on the data warehouse mode in Azure, I think most of you will pick Power BI to have a report on it. But the other mode, the AI mode, or the analytical platform, as it's called here, that would take the same data foundation and train their models, build their features on that, and use, I think it's maybe the most powerful workbench you can have in the machine learning world with MLflow, and this is where Databricks got its roots from. So they're using the same foundation and build their use case upon that and serve their outputs later on in the gold layer too. So we don't have a lot of time. We're just over time. So we have, I already talked about, or Peter showed us a lot of them, all the central services here. And this is where all the services work together on one platform. I hope you get a small glimpse how that can look in your environment. So what are the main takeaways from using Datavault Builder within the Medallion architecture? I would say, taking up the point from Thomas from the beginning, Datavault and lakehouse, there should not be a friction. They should leverage each other. And so this is a very helpful combination, which makes me a lot of fun. It's fun for you too. So short answer, silver is the natural home of Datavault. As we see on the demo, gold can be auto-generated from Datavault Builder. And I talked a lot about that. So we started the journey 10 years ago with batch mode. So why not going on now with streaming first approaches? Because many companies calling out like API first strategies and stuff like that. So this is very good if you look first at handle data as streams, and we can go from that through our whole process. As we see, we need, for all of the steps, we need automation, and then we can turn the complexity of 1,000 of Datavault tables into business outcomes, and we can be very fast in developing that. So at the end, using that platform, using Datavault Builder gives us the technical governance, and it's strict on both sides, on having access to data, on building things on data, because we get all the patterns ready to use, and we're still flexible and can be agile in developing our business use cases. And with that said, I would say thank you. Are there any other open questions?
Hopefully we answered all the questions, and not that we bored you, but you stayed until the end. So thank you a lot. Thank you for your interest, and hopefully meet you soon in another webinar.